Hi, my name is Ayush and I'm a fifth year student from Stratford College, Dublin. For my project, I built a system for developing and executing hybrid classical quantum programs. In other words, some tools to write and run algorithms that consist of both normal classical parts and also parts that run on quantum computers. But first, let's look at how such programs are usually written. You write some code in a normal programming language and send the quantum part of that program to a master controller, whose main job is to execute those instructions on a real quantum device, process the result, and send it back to you. However, consider this scenario. Here is a hybrid program. You can see here that we want this first classical bit to run on the laptop. We want the second quantum portion to run on the quantum computer. But we want this third bit here to run on the classical controller for the quantum computer, for tasks such as post-processing results and so on. But how do we actually write the code for the controller? We could always just split this program into two different ones and send one off, but that can lead to you writing code twice, and also isn't a very intuitive programming experience. A possible solution is to have a region in computer memory which is shared between the laptop and the controller, a place through which they can both communicate and share code and data. However, there aren't really many software tools to enable and manage this shared memory. That's why I built an operating system kernel and a programming language. The operating system basically manages the shared memory, coordinates programs that are using it, and provides functions to efficiently read and write to it. The programming language is for writing programs to run on the OS. Among other things, it provides an interface with the system, therefore enabling programmers to write code without actually getting into the details of shared memory. Here's an example of a program written in my language. If we were to run this code, then these lines here would all run locally, like on the laptop. But this line of code here instructs the OS to take this function and all that it depends on, and put it into the shared memory where the controller will execute it. This line of code then instructs the OS to run this function while the controller finishes what it's doing up here. To test my code, I extended a popular open source classical computing emulator called QEMU by adding a quantum simulator that I wrote. I've tested multiple programs on the simulator, so I can reasonably say that it works, even though there are still aspects that could be optimized. Now, although I've tested the system on a simulator, would it work on actual quantum devices? Well, you need to change some of the controller software, but the actual design of the operating system and language would stay pretty much the same. Thank you for watching this video, I hope you enjoyed it, and have a great day.